Pure functions. A pure function is a function that returns a value that is computed based on its arguments. Pure functions take at least one argument and always return a value or another function. They do not cause side effects, set global variables, or change anything about application state. They treat their arguments as immutable data. In order to understand pure functions, let's first take a look at an impure function. Var Frederick equals. Name Frederick Douglass, can read false, can write false. Function self-educate. Frederick.can read equals true. Frederick.can write equals true. Return Frederick. Self-educate. Console.log Frederick. / name Frederick Douglass, can read true, can write true. The self-educate function is not a pure function. It does not take any arguments, and it does not return a value or a function. It also changes a variable outside of its scope. Frederick. Once the self-educate function is invoked, something about the world has changed. It causes side effects. Const Frederick equals. Name Frederick Douglass, can read false, can write false. Const self-educate equals person equals. Person.can read equals true. Person.can write equals true. Return person. Console.log self-educative Frederick. Console.log Frederick. / name Frederick Douglass, can read true, can write true. / name Frederick Douglass, can read true, can write true. Pure functions are testable. Pure functions are naturally testable. They do not change anything about their environment or world, and therefore do not require a complicated test setup or teardown. Everything a pure function needs to operate it accesses via arguments. When testing a pure function, you control the arguments, and thus you can estimate the outcome. You can find more on testing in Chapter 10. This self-educate function is also impure. It causes side effects. Invoking this function mutates the objects that are sent to it. If we could treat the arguments sent to this function as immutable data, then we would have a pure function. Let's have this function take an argument. Const Frederick equals. Name Frederick Douglass, can read false, can write false. Const self-educate equals person equals. Person, can read true, can write true. Console.log self-educative Frederick. Console.log Frederick. / name Frederick Douglass, can read true, can write true. / name Frederick Douglass, can read false, can write false. Finally, this version of self-educate is a pure function. It computes a value based on the argument that was sent to it, the person. It returns a new person object without mutating the argument sent to it and therefore has no side effects. Now let's examine an impure function that mutates the DOM. Function header text. Let h1 equals document.create element h1. h1.inner text equals text. Document.body.append child1. Header caused side effects. The header function creates a heading on element with specific text and adds it to the DOM. This function is impure. It does not return a function or a value, and it causes side effects a changed DOM. In React, the UI is expressed with pure functions. In the following sample, header is a pure function that can be used to create heading on elements just like in the preview. As example. However, this function on its own does not cause side effects because it does not mutate the DOM. This function will create a heading 1 element, and it is up to some other part of the application to use that element to change the DOM. Const header equals props.title. Pure functions are another core concept of functional programming. They will make your life much easier because they will not affect your application's state. When written in functions, try to follow these 3 rules. 1. The function should take in at least 1 argument. 2. The function should return a value or another function. 3. The function should not change or mutate any of its arguments. Data transformations. How does anything change in an application if the data is immutable? Functional programming is all about transforming data from one form to another. We will produce transformed copies using functions. These functions make our code less imperative and thus reduce complexity. You do not need a special framework to understand how to produce one dataset that is based upon another. JavaScript already has the necessary tools for this task built into the language. There are 2 core functions that you must master in order to be proficient with functional JavaScript: array.map and array.reduce. In this section, we will take a look at how these and some other core functions transform data from one type to another. Consider this array of high schools. Const schools equals Yorktown, Washington Lee, Wakefield. We can get a comma delimited list of these and some other strings by using the array.join function. Console.log schools.join / Yorktown, Washington Lee, Wakefield. Join is a built-in JavaScript array method that we can use to extract a delimited string from our array. The original array is still intact. Join simply provides a different take on it. The details of how this string is produced are abstracted away from the programmer. If we wanted to create a function that creates a new array of the schools that begin with the letter W, we could use the array.filter method. Const W schools equals schools.filter cool equals school 0 equals W. Console.log W schools / Washington Lee, Wakefield. Array.filter is a built-in JavaScript function that produces a new array from a source array. This function takes a predicate as its only argument. A predicate is a function that always returns a Boolean value, true or false. Array.filter invokes this predicate once for every item in the array. That item is passed to the predicate as an argument, and the return value is used to decide if that item shall be added to the new array. In this case, array.filter is checking every school to see if its name begins with a W. When it is time to remove an item from an array, we should use array.filter over array.pop or array.splice because array.filter is immutable. In this next sample, the cut school function returns new arrays that filter out specific school names. Const cut school equals cut, list equals list.filter cool equals school equals cut. Console.log cut school Washington Lee, schools.join. // Yorktown Wakefield. Console.log schools.join n. // Yorktown. // Washington Lee. // Wakefield. In this case, the cut school function is used to return a new array that does not contain Washington Lee. Then the join function is used with this new array to create a star delimited string out of the remaining two school names. Cut school is a pure function. It takes a list of schools and the name of the school that should be removed and returns a new array without that specific school. Another array function that is essential to functional programming is array.map. Instead of a predicate, the array.map method takes a function as its argument. This function will be invoked once for every item in the array, and whatever it returns will be added to the new array. Const high schools equals schools.map cool equals school high school. Console.log ischools.join n. // Yorktown High School. // Washington Lee High School. // Wakefield High School. Console.log schools.join n. // Yorktown. // Washington Lee. // Wakefield. In this case, the map function was used to append high school to each school name. The schools array is still intact. In the last example, we produced an array of strings from an array of strings. The map function can produce an array of objects, values, arrays, other functions and Java. Script type. Here is an example of the map function returning an object for every school. Const high schools equals schools.map cool equals name school. Console.log high schools. // name Yorktown. // name Washington Lee. // name Wakefield. // An array containing objects was produced from an array that contains strings. If you need to create a pure function that changes one object in an array of objects, map can be used for this, too. In the following example, we will change the school with the name of Stratford to HB Woodlawn without mutating the schools array. Let schools equals name Yorktown, name Stratford, name Washington Lee, name Wakefield. Let updated schools equals edit name Stratford, HB Woodlawn, schools. Console.log updated schools 1 // name HB Woodlawn. Console.log schools 1 / name Stratford. The schools array is an array of objects. The updated schools variable calls the edit name function and we send it the school we want to update, the new school, and the schools array. This changes the new array but makes no edits to the original. Const edit name equals old name, name, equals. A dot map item equals. If item dot name equals old name. Return. Item, name. Else. Return item. Within edit name, the map function is used to create a new array of objects based upon the original array. Array.map injects the index of each item into the callback as the second argument, the variable I. When I is not equal to the index of the item we wish to edit, we simply package the same item into the new array. When I is equal to the index of the item that we wish to edit, we replace the item at that index in the new array with a new object. The edit name function can be written entirely in one line. Here's an example of the same function using a shorthand if/else statement. Const edit name equals old name, name, equals. A dot map item equals, item dot name equals old name. Item name. Item. If you need to transform an array into an object, you can use array.map in conjunction with object.keys. Object.keys is a method that can be used to return an array of keys from an object. Let's say we needed to transform schools object into an array of schools. Const school equals Yorktown 10, Washington Lee 2, Wakefield 5. Const school array equals object.key key equals name key, wins schools key. Console.log school array / / / name Yorktown / wins 10 / name Washington Lee / wins 2 / name Wakefield / wins 5 / In this example, object.keys returns an array of school names, and we can use map on that array to produce a new array of the same length. The name of the new object will be set using the key, and wins is set equal to the value. So far we've learned that we can transform arrays with array.map and array.filter. We've also learned that we can change arrays into objects by combining object.keys with array.map. The final tool that we need in our functional arsenal is the ABL. IT to transform arrays into primitives and other objects. The reduce and reduce write functions can be used to transform an array into any value, including a number, string, boolean, object, or even a function. Let's say we needed to find the maximum number in an array of numbers. We need to transform an array into a number, therefore, we can use reduce. Const ages equals 21, 18, 42, 40, 64, 63, 34. Const max age equals ages.reduce max, age equals. Console.logage, max equals age, max. If age, max. Return age. Else. Return max. 0. Console.log max age, max age. / 21, 0 equals true. / 18, 21 equals false. / 42, 21 equals true. / 40, 42 equals false. / 64, 42 equals true. / 63, 64 equals false. / 34, 64 equals false. / max age 64 The ages array has been reduced into a single value, the maximum age, 64. Reduce takes two arguments, a callback function and an original value. In this case, the original now value is 0, which sets the initial maximum value to 0. The callback is invoked once for every item in the array. The first time this callback is invoked, age is equal to 21, the first value in the array, and max is equal to 0, the initial value. The callback returns the greater of the two numbers, 21, and that becomes the max value during the next iteration. Each iteration compares each age against the max value and returns the greater of the two. Finally, the last number in the array is compared and returned from the previous callback. If we remove the console.log statement from the preceding function and use a shorthanded /else statement, we can calculate the max value in any array of num. As with the following syntax. Const max equals ages.reduce. Max, value equals, value, max. Value max, 0. Array.reduce right. Array.reduce right works the same way as array.reduce, the diff. Difference is that it starts reducing from the end of the array rather than the beginning. Sometimes we need to transform an array into an object. The following example uses reduce to transform an array that contains colors into a hash. Const colors equals ID zcap, title rad red, rating 3. ID chsof, title big blue, rating 2. ID gritch, title grizzly gray, rating 5. ID ryhbhsl, title banana, rating 1. Const hash colors equals colors.reduce hash ID title rating equals hash it equals title rating return hash console.log hash colors // zcap / title rad red / rating 3 / chsof title big blue / rating 2 / gritch / title grizzly gray / rating 5 /ryhbhsl title banana rating 1 / In this example, the second argument sent to the reduce function is an empty object. This is our initial value for the hash. During each iteration, the callback function adds a new key to the hash using bracket notation and sets the value for that key to the ID field of the array. Array.reduce can be used in this way to reduce an array to a single value, in this case, an object. We can even transform arrays into completely different arrays using reduce. Consider reducing an array with multiple instances of the same value to an array of distinct values. The reduce method can be used to accomplish this task. Const colors equals red, red, green, blue, green. Const distinct colors equals colors.reduce. Distinct color equals distinct.index of color equals -1. distinct, distinct, color. Console.log distinct colors. / red, green, blue. In this example, the colors array is reduced to an array of distinct values. The second argument sent to the reduce function is an empty array. This will be the initial value for distinct. When the distinct array does not already contain a specific color, it will be added. Otherwise, it will be skipped, and the current distinct array will be returned. 3 For more on higher order functions, check out Chapter 5 of Eloquent JavaScript. Map and reduce are the main weapons of any functional programmer, and JavaScript is no exception. If you want to be a proficient JavaScript engineer, then you must master these functions. The ability to create one dataset from another is a required skill and is useful for any type of programming paradigm.